Part 3 of our lesson on the EX24 case study will focus on the non-Reentrant Spinlock, which is a class that emulates a compare and swap style spinlock with non-recursive semantics using the Java VarHandle class. The non-Reentrant Spinlock class implements the lock interface, just like the ReentrantLock class, but its implementation is going to use a VarHandle. Now, we talked about VarHandle before. VarHandle is basically this wrapper around very low-level compare and swap operations. And you can see here that we initialize this in a static block for the class by looking up the method handle and then using that to find the var handle or to make ourselves initialize a var handle. And what we do is we connect it to this volatile variable that's a field in the class called value of type int that it finds in the non-Reentrant Spinlock class. So using the magic of Java reflection, we get back a var handle. And then we're going to be able to use that to do compare and swap operations atomically on that value field, which note again is volatile. Let's take a look at a couple of the methods. Here's Trilok. So Trilok is going to use the compare and set method on VarHandle to take this object and try to change the value of value atomically from 0 to 1. So 1 means it's available, 0 means it's in use. And if we succeed, so if we were able to do that, that means that we've gone from, I'm sorry, I got that backwards. It's going to basically take 1 and try to set it to 0. 0 means it's locked. 1 means it's unlocked. So what we're going to try to do here is we're going to only be able to move it to be locked when the value is 0. So 0 means unlocked. When the value is 0, then we're going to change it, try to change it atomically to being locked. If that succeeds, we have acquired the lock immediately, and we don't have to worry about blocking for this particular call. We were able to do that atomically. Now let's take a look at the lock implementation. So this is the this lock implementation is the version that will essentially spin until it acquires the lock. And the way it does this is it runs a loop that repeatedly checks to see if value equals 0. And if value is 0, in other words, if the lock is available, it will then try to acquire the lock. And the reason for this is described here in these links. So I will paraphrase them, but you should take a look for yourself to read about that. Basically, the idea here is that by only attempting to acquire the lock, if it's available, do we reduce memory contention by not essentially putting too many operations through the cache lines. And these articles both explain how that stuff works. Over here, you can see we have a version of this called lock interruptably, where we have a loop, and it does much the same thing. It tries to get the lock. If it does, we're done. Otherwise, it checks to see if it's been interrupted. If it has been interrupted, then it goes ahead and throws the interrupted exception. And then finally, we have the unlock method, which uses the atomic get and set method defined on VarHandle, which is going to get the current value and attempt it to set it to 0. In other words, it's going to try to release it. And what it's doing is if it turns out that the lock is not actually held by the owner, then it's going to throw the illegal monitor state exception. So essentially here, if unlock is called when it's not locked, in other words, it's not held, then it's going to go ahead and throw that exception. We don't make any attempt at trying to do timed lock support here or implement condition variables. That would be a lot of extra work and beyond the scope of what I wanted to show. So armed with that knowledge, let's go ahead and run the program, and you'll see what it does. So it's using the ReentrantLock first. You see it's counting down, and after a certain number of seconds, it gave up. And now it's trying to run the non-Reentrant Spinlock. And after a certain number of times, it tried to give up and tried to cancel itself, but it self-deadlocked. And therefore, as you can see, the program took the failure route because it had blocked on deadlock. So hopefully this has been helpful to give you a feel for how this particular feature works, concept of using var handles, and you can see how that then also can be applied in the context of this overall test where you can see how you can differentiate between reentrant locks and non-reentrant locks with respect to callbacks in object-oriented frameworks.